Hello, welcome back. Today let's try to solve another Leetcode problem. Number 60, permutation sequence. So we are giving a set. The numbers is going from 1 to n, contains a total of n factorial unique permutations. So this means if we have a number 1, 2, 3, so the n equals to 3, it means we're gonna have 6 permutations. And we are giving the n and k just to return the k's permutation sequence. For example, n equals to 3 and k equals to 3. So the third one will be 2, 1, 3. And now I'm going to explain it in whiteboard for the example 2. After that, I will go to the code editor to finish the coding. Now let's go to the whiteboard first. As you can see, if we are going to calculate the n equals to 4 and k equals to 9, it means how many, so for n equals to 4, how many permutations? So it is like 4 factorial. So what is 4 factorial? It is 4 times 3 times 2. So it is 24. So in total there are 24. But we are going to calculate only the ninth position. So for the ninth position, it is 2, 3, 1, 4. So why? Because for 1, if it is started for 1, after 1, how many permutations we have? It means after 1, it will be 2, 3, and 4. The permutations will be 6. It is 3 factorial. So 3 factorial equal to 6. It means if we are going to calculate k equals to 1 to 6, it is okay with the starting with 1. Yeah, if k equals to 9, it means it is more than 6. We have to check the next number. So we're going to check the starting number with 2. So if we are started with 2, so after 2, how many factorials of them after 2? So after 2, it will be 1, 3, and 4. So of course, there will also be 6. Yeah, but we've already consumed 6. It means 9 plus 6 is 6. It means here, the k equals to 3. So 3 is in the range of 1 to 6. And open and with close included. So 3 is in the range is 1 to 6. So it means the permutation must start with the first number with 2. So it means 2 is okay. Now we are going to check the second start number, the second number with 1. So with 1, we have 3 and 4, 4 and 3. It means we also consumed 2 numbers. So 3 minus 2, it is 1. Now we're only left with 1 numbers, but this one starting with 1 is not possible. So we're gonna try another number starting with 3, because the number after 1, 3, 4, after 1, 4, 3, which is bigger than those 2 numbers, it is start with 3. So it will be 3, 1, and 4. Now this 3, 1, and 4 plus the first number 2 plus with these 3 numbers, it is our result 2, 3, 1, and 4. Actually, the algorithm is also calculated like this for speeding up the time. Now, I'm going to define array nums. So inside the nums, it will be the numbers 1, 2, 3, and 4, because these nums will be used for me to decide which number is the first. For example, in our example, the number 2 will be first, so I take out this number 2. So I just pop out this number 2 from the index 1, pop it out, and what's left behind is 1, 3, and 4. And for 1, 3, and 4, I will update this k equal to 3, and I'm going to check for the next step. So how I'm going to check each step? I'm going to use a factorial. So for the first number, the factorial will be n minus 1. N equal to 4, 4 minus 1 is 3. So 3 factorial is 6. I'm going to check the second. While I'm going to check the second, it means this factorial 6 and my k is 3. So my k is less than the factorial. So I'm going to define a variable code. So k is less than my code. Code is my factorial 6. Yeah. So it means I'm going to take out this number 2 first, as I put it here. And then I'm going to check the next one. The next one will be 1, 3, and 4. So inside 1, 3, and 4, I'm going to update the k. K would be equal to 3. and then I'm going to check again. So the k equals to 3, and what is my count? So my count will be 2 factorial, because at this moment, I only have 1, 3, and 4, n minus 1, and now n minus 1 for this one, or n minus 2, 1, 2, 3, and 4, n minus 2, it is 2 factorial. So 3 is more than 2, so the count is more than k. So I'm going to take the next number. So what is 3 is more than 2, but it's not yet 3. Even this 3 is more than 2, my count is more than k, so I have to check the next one. So what is my next number? It is 3, because 1, 3, and 4, I'm going to check it one by one. So the next number will be 3. So I'm going to take it as 3. So my result for this k would be equal to 1. So what is the factorial of 1? Because I only left with 2 numbers, 1 and 4. So the factorial n minus 1, 2 minus 1, it is 1. Factorial 1 is equal to this 1. So it means my count is less than and equal to k. So when the count is less than and equal to k, so I'm not going to update my index for these numbers. So I'm only take out the numbers one by one. I'm going to take this one out, and then so yeah, it is still the count is less than or equal to k. I'm going to take out that 4. Yeah, it may be confusing, but basically the algorithm is use factorials to speed up the numbers. For example, this is 9. It is a big number. Maybe we can use a factorial. 3 factorial, it is 6. We take out this 6. What we left behind, it is 3. Maybe we can minus a factorial of 2. 3 minus factorial of 2, it is 1. So 1 is our final result, because 1 is always factorial. This count is a factorial. The smallest number is 1. It's always less than and equal to our k. Yeah, if it is less than and equal to our result k, we can get the result. Now let me go to the code editor to finish this coding. While I write the code, I will explain what happened for each of the conditions. So I'm going to define a variable result as an empty string, and also I'm going to define a nums. So inside of the nums, I'm going to put the string of numbers. So string I. For I in range, the numbers will start from 1 to n plus 1. Now, I'm going to check. So finally, I'm going to return the result. But before that, I'm going to check for I in range starting from 1 to n plus 1. So here, for this I, it means I'm going to check the I'm going to check the factorials. This I means I'm going to check if I equals to 1, so my factorial will be n minus I. It means I'm going to check from the biggest factorial. Factorial 3 is 6 for this example too. So I'm going to have a count. So the count would be the factorial n minus I, because I'm going to check the biggest factorial first. So this is why I'm going to define a I from 1 to n plus 1. So the biggest I is n. So n minus n, as you can see, it is 0. Factorial 0, it is still 1. Yeah, so this factorial and this count, yeah, so the smallest count is 1. Let's prepare an index. So the index would be start from 0. So this 0 means for the nums, it will start from the first position. So the first place of the nums, it is 1. So we'll check the 1 first, and then 2 and 3. So this is, for this nums. The index is preparing for this nums array. Now we are going to check. So while this count is, let's check the k. While k is more than the count, it means we can update the count. We can update the k first. So k should be minus the count, and index, of course, we can plus 1, because if the first index, like from 0 index, it is 1, for the number 1, it's not okay, it is still bigger. We're gonna check the next one. Maybe it will start from 2, maybe start from 3 or 4. Yeah, this is why we're gonna use a while loop to check the count. After updating, if it goes out of the loop, the result should plus the nums. We need to take this index. Yeah, so this is we're gonna take the numbers one by one. So the result, for example, if it is a 9, we're gonna take out this 2, because for number one, we're gonna check it is still bigger. So if it is bigger, k here equals to 9. 9 more than 6, count is 6. 9 more than 6, it means the k should be minus the count. K should equal to 3, but the index should plus 1. From the first place, it is 1. Now, it will go to the number 2. The index will go to 1. The numbers will be 2. So this is why the result will take out this number, nums index. After that, so the nums should also pop out this index, because we're gonna not use this index anymore. We just pop it out. Yeah. Actually, this is the entire code. It's not so long, but it's a little bit difficult to understand, because everything is about mathematics. Everything is about formula. Now let me run it to check if it is working. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and it's pretty fast. Yeah, thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.